In previous videos, I talked about inheritance, and in this lesson, I would like to talk about using the super keyword as it relates to inheritance with classes and objects. All right, so let's first talk about this little case example. Over here in the upper right, I have a picture of a video game, of the game hockey in particular, and every person on the rink shares some certain attributes like a jersey number, height, weight, and maybe a position on the screen, or this could be a position on a real hockey rink if you want to use an XY position. And each of them know how to skate in terms of a method. But the thing is, there's no just plain hockey player on a rink. That is something that all of them share, but they're actually more specialized than that. If I go to the bottom of this hierarchy, um, we start with the offensive players. First off, there's a wing, and a wing is the person either here or here. We could call it the top or the bottom, or the left and the right. And so if we said side of the rink, we could say left or right as an attribute. And something else about wings is perhaps we could count the number of goals that they've made during their career or during a particular season. The person in the middle is very similar to them, but they don't have necessarily that same side of the rink, but they do have a special behavior, which is do face off. So centers always start off when they throw down the puck and start a game, or start after a score has been made. All right, let's go to the defenders now. One of the defenders here could be just a regular defender, and defenders actually do this special behavior called a slap shot. So if all of these players moved forward and the three of these guys, these offensive players, were close to the net, these defenders would be hanging out in back. They tend to be big, strong guys, and if the puck escapes and goes out to them, they wind up and they give a really strong hit, and we call that a slap shot. Another defender that we don't see on the screen would be the goalie. And so on this particular team in green, off the screen would be the goalie, who has a method or a behavior that they can do called block puck. And they could do this with their hands, and nobody else is really allowed to do that. Okay, in between those two things, we could say, generically speaking, in addition to a player having these attributes, people who are on offense are intended to shoot at the goal. So this is a unique behavior to offensive players. Okay, this isn't a perfect example because technically defensive players can score as well, but this is just to demonstrate the idea of classes and inheritance. Another thing that they might have as an offensive player is they have an offensive rating. If you go to sports sites, there's usually some number associated with a player in the season that indicates whether the team does better or worse when that particular player is on the floor. So maybe all offensive players have this particular rating, but as we go down to specializations, there are other unique things about them. So if we look at an individual player down here, they have all of the attributes of the most parent class of player. They also have all of the attributes and methods of the class which is directly above them, which is their direct super class. And I could say a similar thing about what's going on over here. There's a defensive rating, and an action that a defender should do is defend, of course. Okay, I would like to build out some of this to demonstrate the use of the word super. So let's open up Visual Studio Code. Hopefully you have it pre-configured so that it has live server enabled as a plugin. I have added a file just now called super.html. So I'm going to minimize that pane, and I'm going to start off my HTML document with that exclamation point and then hit return. So let's go ahead and start with our class of type player. And then we'll kind of work on through this hierarchy and test all of them and learn about super in the process. So first, I will type in my script tag, and then I will type in class player. And I'm going to first add their instance variables or attributes or properties, whatever it is you want to call them. And in this case, if you remember the diagram, it's jersey number, height, weight, X position, and Y position. And I added in Hungarian notation to indicate whether I thought these were integers or floats. Okay, I want to be able to use a constructor so that when I create instances of this class that I can pass in all of the parameters that will be assigned to this particular object. So let me set up my constructor. Constructors look like methods, and they take parameters like methods. So I'll say constructor that takes parameters. And my parent class, my player class, is going to take, well, first off, let's write the word constructor and put some parentheses here. And the thing that it's going to take are a jersey number. And some people get a little bit confused whether or not these are the same things or not. And I try to emphasize that these are temporary variables that need to be assigned to these variables using the this dot notation. And just to make it clear that these are temporary variables that are only in existence for while the method constructor or constructor method is running, let's go ahead and just call them temp. So I'll say I height. Now we haven't shown the syntax for calling this yet, but we're working ahead and thinking about what we're going to pass. Oops, and I forgot to say temp. All right, add in my curly braces. And once I've received those variables, I need to do something with them. So I will assign them to my actual object. So I'll say this dot I jersey number equals I jersey number temp. This dot I height equals this dot I height temp. This dot I weight equals, oops, I messed that up. Sorry about that. This dot I weight equals I weight temp. This dot fx position equals fx position temp. This is a lot of typing, isn't it? This dot fy position equals, again, the thing that was passed, fy position temp. Okay. And I want to make it clear that in our constructors, we don't just have to limit ourselves to assigning variables. We can also do anything else that you can do in code. We can call out to other functions. We could do something elaborate here, like writing out to a log. But in this case, just to demonstrate this, I will use an alert statement to show when this particular constructor has been called. So I'll say additional code could be anything. And in this case, I'll say alert, I'm a total player. And this kind of has a little double meaning there. We're just being silly. We, of course, are referring to a hockey player. All right, so we've got the attributes, we've got the constructor, and then also from our previous diagram, we had an instance method, so a method that will be available on the class instances, and that was skate. And we could say alert, wee, I'm skating. All right, now I could create an instance of this right now and test it, but I feel pretty comfortable in this case that the code is right, especially since I've written it several times previously. Let's go ahead and move to the next thing in the diagram, which is the offensive player. And I'll pick that up in the next video.